Welcome everyone to EPNOE Talks. Today we have a pleasure to talk with the winner of the first edition of EPNOE Technology Award. The Technology Award was presented to Dr. Jurgen Engelhardt in 2021 in Nantes. So we have a pleasure to have him here with us today. Welcome, Jurgen.
Welcome to all of you, and yeah, thanks again for that prestigious award. So I was really pleased to get that and surprised, actually.
Yes, it was the first time we give this award, and one thing I actually was quite remarkable in your speech when you got the award during the dinner. You said, "Oh, I saw a message coming from Sweden. Oh, maybe I got a Nobel Prize." I remember that. It was very, very interesting. And that somehow was also giving me an insight about there's a lot of work, nice work done in the industry, a lot of talented people working in the industry. And we don't see very much awards given by associations to the industry people, right? But why do you think we have this situation? Is it because of the nature of the work? Is it because of how associations are working? What is your perception?
Yeah, I guess partly it's really the character of the work. The industry very often has the need to work, let's say, behind closed doors to keep stuff secret unless it's already covered by patents, and not to unveil everything they do. Therefore, they are very often not seen at the forefront of sophisticated developments, but yeah, look as a follower more. So the academia might be more visible there. That might be one thing. And another thing is as well, collaboration between industry and academia is perhaps very often bilateral and not in that open mode, so that they are not that visible. So that might be one reason.
Yes, yes. I would also like to emphasize that you are here as Jurgen, okay? You are not here as your company. All the information you give here is a personal opinion, okay? Also, the award was to you, not to your company, okay? It is also very important to emphasize that. And Jurgen, when we look at you have a very impressive CV, right? It's quite interesting to see. You have been studying chemistry at the University of Hamburg. Then you also have a doctoral in macromolecular chemistry at the University of Hamburg. And what we see here in your career, that you have had a very important positions, for example, as project leader, then as head of product and product development, then as associate R&D director, and so on. And all the time, you have been working with polymers or bio-based polymers. So I am quite interested to know, and maybe our viewers also have interest to know, how is your evaluation on how this industry of bio-based polymers changed in the last 20 years, or how this industry evolved?
Yeah, you rightfully mentioned I worked most of the time in polysaccharides, actually in cellulose, but for sure you have a broader view on the other polysaccharides as well, working on that. I guess back in 1990, where I started in the industry with Wolfertsrode, I had the pleasure to be on a regular basis on the Zellcheming conference, where the so-called Cellulose-Chemiker Rundgespräche, Cellulose Chemist Roundtable, took place, a conference of the German, but as well European cellulose chemists. And I guess at that point in time, it was a strong focus on textile fibers, on rayon for tires. So cellulose regenerated and native fibers were in scope. They discussed broadly X-ray signals from measurements, or the properties of viscose solutions, filter values, and aging behavior. And there was low interest, or public interest at least, on derivatives. There were only some hotspots, I would say, worldwide, who dealt with cellulose derivatives. The know-how and work was more with the companies, so with Eastman or Rhodia or Bayer for the cellulose esters like cellulose acetate or acetobutyrate or propionate, or with Wolfertsrode and Höchst and Henkel and Hercules, for example, for CMC, HDC, or the MCs, or with FMC for microcrystalline cellulose. but not in the academia that strong. And even though at that point in time, the cellulose was already a regenerative source, it was already a given, so to speak, it was actually not the driver to use cellulose at that point in time. It was still the century of fossil resources for the polymer industry. And even though I guess in that range, the Club of Rome, they predicted that oil will be out in 1992 or gas in 94. There was a driver by science technology, but as well business interest to identify more fossil resources. They found new oil deposits. They recovered oil sands. New technologies like horizontal drilling or fracking were developed. And so it prolonged the lifetime of the synthetic polymers. Nevertheless, beside these developments, I saw as well that general trends in the science and technology influenced the polysaccharide and cellulose investigations. So in the 80s, where I made my study and PhD study, as well on liquid crystalline synthetic polymers, I saw that influenced as well the cellulose area. HPC was known to be liquid crystalline or to build liquid crystalline phases, but as well unusual new derivatives were synthesized to dig more into that field where Kevlar-nomics and Vectra were playing at that point in time. So then in the 90s, where I started here, actually, I saw that there was a raising awareness in the need for degradable polymers. That was triggered at that point in time by the tightness of landfill space, which were really not available anymore in Central Europe, at least. And that drove the interest in cellulose itself and derivatives, as well in other polysaccharides. So the thermoplastic starch or cellulose derivatives, thermoplastic ones, were developed, and we actually executed a project on cellulose lactates and mixed ethers, which were or made it to a molded cardboard trim actually, but unfortunately the time was not due. It hadn't come for the automotive industry to buy in. I guess the plastic recycling and waste incineration solved that issue of the landfill shortage, and so it paused a little bit at that point in time. So another technology I saw was the nanotechnology hype a decade later or so. So we were among the first ones to file IP on nanoscale celluloses more than 15 years ago. Since then, the cellulose nanocrystals, the micro nanofibrillate cellulose, they developed steeply from lab to pilot or even plant scale. So that was another area in that 30 years I overlook. And then I guess in the last decade, really, the growing overall awareness for sustainable solutions brought back the strong interest and focus on polysaccharide sources and the options to modify them, and brought new players to the field. There were startups and spin-offs from companies, from universities, but as well players from new regions in the world came to the market. And I guess as well in the broader industry, the interest in these renewable resources grow quite steeply. So one example is, for example, paper. Paper is really in the scope of the plastic companies because it has a collection and recycling loop which works in contrast to other plastics, which could not be really collected in a clean manner. And another field is the encapsulation, where polysaccharides were used to fulfill the requirements of the expected ECHA microplastic restrictions in Europe. So these are fields where for sure there's interest growing. And the word carbon footprint or life cycle assessments, I guess I never heard them as often as in the last 5 years. Mm-hmm. So that's really the revival of these trends. And last but not least, perhaps what I observed over the 30 years was as well a steep development in sophisticated analytical tools. So that is so important. to determine the structure of the polysaccharides and their derivatives. So there were so many 2D methods, coupled chromatography or sophisticated NMR solutions, particle analysis on shape, size, morphology, so microtomography and the like, you name it. They enabled us as well to develop the structure property relation, the correlation, but as well understand where these correlations come from. And that is really a fundamental need to develop new products and tailor them to the needs of the applications.
Yes, that's interesting. Yes, sometimes we see people that are outside our field talking, oh, cellulose is an old polymer, all questions, all research questions are answered. What would you say to these people? They say that all research questions related to cellulose are answered. It's really an old material, the book is closed.
For sure not. If they are able to write down for me just the structure of a simple carboxymethyl cellulose, the real structure involving all the different elements and how they are distributed, then they might convince me that everything is explored, but no one is able to do that yet. It's statistics still. The behavior of the cellulose nanoparticles, if they are on cellulose 1 or cellulose 2, is just started to explore. There's so much more to do. And that was one thing which surprised me as well in the beginning, where I started with cellulose, what might be open there. And after 30 years now being in that field, there is more open than we still know. So for sure, it's not a closed book. It's just the first chapter which has been written.
Yes, and to tackle these challenges, Jurgen, how do you see the collaboration between industry and universities? Because as you mentioned in the beginning, there is a lot of knowledge or also from industry. I mean, you see in Germany, for example, the knowledge in cellulose chemistry in Germany is impressive, right? Or in different industries. But how this could be more synergistically exploited, for example, in collaboration between researchers, young researchers, experienced researchers and industry in your point of view?
Yeah, I guess actually you can't be the deep expert in everything, that is for sure. And therefore, to use the diversity of the disciplines today, you need to collaborate with external experts, with institutes, with academia. That is really need to compete in the market from my, I'm convinced that's the way. And that will be more and more the case the more the technologies develop in specialty directions. So we always try to leverage in capabilities from external sources, mainly academia, universities, institutes, less from commercial providers, so to speak. And we try to leverage in as well, not only capabilities, but as well external ideas and views. And externals who challenge your own internal view. That is critical for me. So they have multiple benefits actually to work with external resources in academia and institutes. Actually, you should always look to work with the best, so that boosts as well your patent track record, as we discussed, but it helps you as well to have a positive impression of what it brings to you. And one field where I see it really beneficial and critical is the fundamental research. We try to support that always, and it's very often more easy to do fundamental research externally, decoupled from the daily business distractions, than internally. So the cellulose industry, and in particular our business, was eager in the early 2000s, for example, to support the creation of the Competence Center for Polysaccharide Research in Jena-Rudolstadt. There has grown one of these hotspots of expertise for sure. And we supported as well a lot of other groups and teams to work on the analytics of substituent distribution with the University of Braunschweig, on rheology or NMR or cellulose characteristics at Hamburg or Tarrant, and the fundamental work with Fraunhofer Institute of Applied Polymer Science, or the Mainz Paris with Patrick Navarre in the early days of EPNOE, as well as with Tatiana Butova. So these are examples of some of the valued European partners I had the privilege to work with. And there's one one condition from my point of view, which is needed to have successful cooperation with academia, with external institutions, that is always to have to be open as possible. So very often you cannot unveil everything, but you have to try to be open as possible about the topic, about the targets, and you have to build a mutual trust, a trustful relation. Otherwise, it won't work. That was key always in all these cooperations we had, to build first the trust into each other on all the, let's say, confidentiality, but as well to the openness and the work. For sure, there will be need to sign CDAs and MTAs and JDAs and all that stuff, but trust is key to go into successful cooperations with external partners.
Yes, yes, trust is very important in order to have openness and to create an environment for innovation. Yeah,
yeah.
But it's very impressive. Your patent track record is very impressive. I mean, you have more than 50 patents, right? So you are really an innovator. I'm quite interested to know about also your view a little bit on global scale, for example. How do you think that Europe, innovation-wise, is doing in comparison, for example, with the United States or Asia? What is your perception about what we are doing in Europe? Should we improve? Should we follow what we are doing at the moment? What is your view?
Yeah, I guess my track record actually is built on trying to work with the best, as I mentioned, always. Then it comes by itself. So if you share your ideas openly and look for cooperation internally and externally, it sums up. So luckily, my environment was always supportive to look into the broader field and as well to think exploratorily. So then it's not a big deal to make a few filings a year. And cellulose wasn't the limit. So we looked as well into guar starch derivatives, binoxylin, or we tried to mimic chitosan by cationic celluloses. I mentioned already the thermoplastic biodegradables or other non-commercial cellulose derivatives like DCMC or DHPC or SEC. And as well, alternative activation was on our radar to do, for example, activation by using enzymes, exoglucanases, or E-beam actually as an activation method, as well as working in a homogeneous solution or doing cross-linking. So that sums up to that number easily. And actually, some work is as well done on not only exploratory work externally or internally, but as well on the core process and products and applications we have. So that as well adds to this number. So the number, therefore, is really feasible. And yeah, I started at the PhD thesis already with the first filings. At that point in time, I was on the dark side of the force, so to speak, working with highly thermostable polymers, which didn't dissolve and for sure didn't degrade. But luckily, I made it to the renewable future. And I guess there is a lot of additional IP space open there. If I look into the global situation, we see that there is a huge number of filings being generated in Asia and China in particular. So a lot of utility model patents are filed there, and the practice to grant them to short notice, so to speak, is driven by the Chinese funding policies. Nevertheless, it makes the whole IT space, from my point of view, or will drive it to a critical point in the future, because you can't observe this number of patents on a continuous basis. And in the end, you have really to take care to focus on your needs and cover the fields you need to use as early as possible by own patents. That's well running in the US and in Europe as well, I guess. For sure, patenting is an expensive undertaking. So making patents, filing them, protecting them, keeping them, as well opposing patents from others where you need your interest to be secured is quite expensive. And therefore, I guess we have to drive the focus more on the quality of filings to the real stuff we need, instead of making numbers, having the most filings, in company comparison or continent comparison, but look onto the quality of the patents. They should be really valuable, usable, and cover what we like really to protect.
Yes, yes, yes. Quality and excellence is very important, yeah, to do more than just quantity. Yeah? So, talking about quality and excellence, we are interested to know about, with all your experience and your expertise, and what are your views about the future of the area of polysaccharide research? What is like your dream vision about how this area is going to develop, and what are the elements that could be taken into consideration?
Mm. Yeah, I guess my wishes and my dreams really go in line with what I expect what will happen. So I guess for the future, the term sustainable solutions will be the headline for all developments. Already yet, many, at least the larger companies, implemented the sustainability into their management systems, into their project approval systems, and all of that. That will come. I see there is a gap still that is in tools to measure sustainability. What does that mean? So there are these aspects given by the United Nations 2030 agenda, the 17 sustainability development goals. There are other definitions of sustainability, but it's a huge term which can really turn everything in the right direction if it's applied appropriately. And there has work to be done to create tools, to create definitions, to agree on those, to talk the same language. I'm convinced that our planet is not set up by nature to host 8 billion humans. That's for sure. So we have to overcome this defect by nature, so to speak, by our brain power. We have to act responsibly and to develop solutions to solve global warming, sufficient food and health for everyone, to overcome individual ignorance as well. That is a challenge for the future. And I have to admit, I'm not really a role model for that. So my old diesel car is still waiting for the biofuels to come, and I don't have solar shingles yet on my roof. So sorry for that. But actually, I'm glad that the company I'm in currently here developed already materials for better batteries, for tasty meat analogs to save environment, and as well biodegradable additives for multiple applications. So from that point of view, I guess there will be need continuously to look for efficient and more efficient technologies. So perhaps to give one example, I recall from my early days being a subsidiary of Bayer. We got a new daughter, and they were able to do genetically modification on plants. So we talked about making new polysaccharides in plants, not to harvest them just by extraction, but really make the plants doing them like potatoes do starch, to do alternane or neoamylose or mutane or hyaluronic acid, stuff like that run in plants. It did not realize at that point in time, but now 20 years later, I'm in a different environment, so by some company changes. And actually, we have a new technology available called DEB, Designed Enzymatic Biopolymers. So that enables now most of the same stuff we looked at 20 years ago by tailored enzymes, just by using a fermenter without the need for plants, for occupation of a large agriculture area, which is in contrast to the feeding need I just mentioned in the beginning. So I guess looking for these more efficient technologies to solve the needs, the issues, and to get new products will help us as well in the future. And yeah, I guess that is the approach we should look for. Don't just take the first best technology, but look for sustainable and most efficient technologies, and sustainable sources like cellulose, like starch, like the other polysaccharides, alginates, carrageenan, and they all will play an important role to secure the future. And that segment will grow for sure, even though there might be monomers for the plastic, for the conventional plastic industry on bio-basis. The renewable resources, the polysaccharides, as well the other natural materials will gain more and more field in the future.
Yes, that is great. That is combination of biochemical methods, the exploitation of fermentation, tailoring of structures and so on is really an amazing area. And of course, polysaccharides have a very big advantage in comparison with other synthetic polymers also, that are these structures and the biodegradability and for many opportunities for bio applications, right? So now I would like to emphasize your views or your advice to people that are starting in research and industry. So what you would advise for your advice for these young people starting? So
yeah, the first advice is just first apply at our company, because the best place to be, for sure. But the other ones might be stay open-minded and really agile to change, but be resistant as well, enough to push and trail and navigate the better ideas and the new approaches through the jungle which is out there, for sure, to get it reality. So it's always good to have a fixed portion of your time for creative exploratory work, independent if you are an R&D or you move perhaps into manufacturing, into marketing, or even sales. Creative ideas can come from every corner, so keep that in mind and serve a portion of that. So other stuff is perhaps sometimes you have to be patient as well. Timing is crucial. So, example, we developed biodegradable systems for encapsulation really 20 years back or so for biological crop protection with Professor Forlop at the Federal Agricultural Institute in Brunswick. So that avoided non-degradable materials in the soil on the fields in the mid of the 90s it was, but it did not get through because the agricultural industry had a different agenda at that point in time. It was not on their to-do list. Nevertheless, today, all those who release encapsulated materials like crop protection, like fertilizer, fragrances, flavors, whatever, they will be highly interested in such approaches. So from that point of view, my last advice would be never forget a good idea and don't be shy to recycle them. Recycling is as well good for ideas, and bring them up when the time is right. Be patient.
Great, excellent. Thank you very much, Jurgen, for your time and for this very nice interview. Thank you very much. Thank you.
Thank you. Bye-bye.